Today we're going to be looking at how to find the scale factor for scale copies. So the first thing that we need to know is that these two rectangles are scale copies of each other. And what that means is that all corresponding lengths change in the same way. So let's look at these two to see what that means. This rectangle has a side length of 2 here. This corresponding side to this 2 is the 6 over here, because they're both on the left side of the rectangle, so they correspond or match up with each other. And we notice that this 2 changes to a 6, which means that it is multiplied by 3. So 2 times 3 is 6. Now this other side length on the rectangle is a 6, and its corresponding side here is 18. So we have to look and see, does the 6 goes from 6 to 18, which again is times 3. So because we're multiplying by 3 for both, all corresponding lengths change in the same way. We also have to look at the angles for scaled copies, the corresponding angles. And if you see here, here's an angle in the lower corner, and we're going to find its corresponding angle on the scale copy. And that, again, just simply means it's in the same exact space. Now, I'm noticing this is a rectangle. All the angles are 90 degrees, which is the same here. So all the angles are the same, and all corresponding lengths are change in the same way. So let's take a look at this. Again, I have two triangles. They are scaled copies of each other. Now, in this case, this is a little different because basically we're going to label the side lengths here for our triangle. So again, we do have the same angles, so we don't have to worry about that. These are all the same angles. And the triangle is equilateral, meaning that all the sides are the same length. If our scale factor, that's what the SF stands for, if the scale factor is 4, that 4 is the number that we are multiplying all the corresponding sides by to get our new side lengths. So in this case, that 3 corresponds with this side. Since it's 4, we're going to do times 4. So this side length is 12. Now for this one, since all the side lengths are 3, we're going to multiply every side by 4. So they're all going to be 12 in the end. So again, what we're seeing is that all the side lengths are changing in the same exact way. And finally, let's look at this one. I chose these two diamonds because I wanted to show you, in this case, the diamond's going from a larger diamond to a smaller diamond. And so a lot of students will say, okay, well, here's a 15 side length, and it changes to a 5. So a lot of students will say, okay, that's dividing by 3, which is true. And this side length is 18, and it goes to 6, which means it's also divided by 3. Now, if I were to ask you for the scale factor of the two scale copies, the scale factor, one thing we have to remember for scale factor is that it's the number that we multiply our side lengths of the original by to get to the scaled copy. So it's not going to be 3 because this is dividing by 3. So basically, we have to figure out what's the same as dividing by 3, but using multiplication. So this goes back to the old keep, change, flip. We know that 15 divided by 3 equals 5, right? That's, in this case, this would be what we're doing to our side lengths. Well, if I were to change this into a fraction problem, 15 would become 15 over 1 divided by 3 over 1. This problem is the same as this problem. Now, if you have fractions and you're dividing them, the rule is, or a lot of you know, the rule is keep the first number the same. So this stays 15 over 1. You change division to multiplication and flip your numerator and denominator. Okay? And this ends up being 15. So now we multiply across. So 15 thirds, which is the same as 15 divided by 3, which equals 5. So the reason I showed you this is because, remember, scale factor is always the number you're multiplying by, okay? So that means if you're dividing by 3, it's the same thing as multiplying by 1 over that number. So 1 over 3. Or if you are, let's say that you found that you have to divide all your sides by 5 to get to your scale copy. Well, 5 isn't your scale factor. It's got to be something that's the same as dividing by 5, but using multiplying. So dividing by 5 is the same as multiplying by 1 over 5, so 1/5. Dividing by 5, multiplying by 1/5, same thing. They give you the same answer, okay? Let's say we're dividing by 9. If you divide all the numbers of your original side lengths by 9, the scale factor isn't 9, it's 1/9 or 1 over 9, because that's what 9 is flipped as a fraction, okay? So if we go back to the problem we were actually looking at, our scale factor here, it's not dividing by 3, so it's not 3, it's actually 1/3. Okay? And that is how you find the scale factors.